Hello everyone, welcome to Classroom of Basic Principles of Steel Structures. In this lesson, we will learn the main factors affecting the performance of structural steel. These influencing factors include chemical compositions, production process, steel hardening, temperature, and stress concentration. In a unit of steel, ferrum accounts for 99%, and carbon and other account for 1%. Carbon is the element that has the most influence on the properties of steel except ferrum. Increasing carbon content can increase steel strength, but can reduce plasticity, toughness, and weld ability. Sulfur is a harmful element. Increasing sulfur content will cause hard brittleness of steel. However, increasing sulfur content can reduce plasticity, toughness, weldability, fatigue performance, and rust resistance. Phosphorus is a harmful element too. Increasing phosphorus content can increase steel strength and rust resistance, but it will cause cold brittleness of steel. Moreover, increasing phosphorus content reduces plasticity, toughness, and cold band performance. Oxygen is a harmful element. Oxygen and sulfur are elements of the same family, so the effect of oxygen and sulfur are similar, and the results are more severe than sulfur. Nitrogen and phosphorus are elements of the same family, so the effect of nitrogen and phosphorus are similar. Manganese is a beneficial element. Increasing manganese content can increase steel strength and can reduce the weld ability. In carbon steel, manganese content is less than 0.7%. Silicon is another beneficial element. Increasing silicon content can increase steel strength and can reduce the weldability and rust resistance. In structural steel, the silicon content is less than 0.4%. Vanadium and titanium are alloy elements in the steel, which can improve the strength and corrosion resistance of steel. However, copper is an impurity component in carbon steel, which can improve corrosion resistance and strength, but it reduces weld ability. The composition and proportion of trace elements in steel can be adjusted through the smelting. But the smelting process will also bring some defects to the steel. And these defects include inconsistency, evenness of chemical composition, and non-metallic inclusions. The casting process determines whether the steel is a burning steel or semi-cured steel or cured steel. However, casting defects are challenging to avoid. Steel rolling can improve the internal structure, eliminate defects, and improve mechanical properties. Steel rolling generally divides into hard rolling and cold rolling. The third effect on the steel properties is the hardening of steel. First, let's understand the age hardening. Nitrogen and carbon are gradually precipitated from pure iron to from free carbonates and nitrates with growth of time, which can restrain the plastic deformation of the pure iron body. Age hardening can increase steel strength and reduce plasticity and toughness. Code working refers to code drawing, code binding, punching, mechanical searing. Just like edge hardening, code working hardening can increase steel strength and can reduce plasticity and toughness. At the temperature raised, the mechanical properties of steel will change a lot. When temperature less than 200 degrees Celsius, there is not significant change. When the temperature is between 430 degrees Celsius and 540 degrees Celsius, the steel strength drops sharply. At the 600 degrees Celsius, the steel is shallow in strength and cannot bear the load. Under the action of negative temperature, the steel strength will increase, and the plasticity and toughness will reduce. Three leading reasons cause stress concentration. The first is cross-section changing of members. The second is the holes, notches, and concave corner of members. The third is the internal defects in the steel of members.
Figure 2.6 shows the schematic diagram of stress concentration. It can see the peak stress appear near the hole. Stress concentration will put the structure in a complex stress state and will be the source of brittle fracture of structure working and negative temperature or dynamic load.
In this lesson, we learned the main factors affecting the performance of structural steel. In the next lesson, we will learn about types of structural steel in China. See you next time.